we can live on. 4.5 billion years ago, the Earth was made by hundreds of mini-planets, or planetesimals. This created a big ball of magma, so nothing could even think about living on Earth if it wanted to. Once all of the molten materials separated into layers, gravity pulled all the denser materials, like iron, into the center, while all the less dense material rose to the surface. This created the layers of the Earth, such as the crust, known as the lithosphere, the outermost layer of Earth, where most living organisms reside on Earth. The mantle, also known as the asthenosphere, is the soft but solid second layer. This is where convection currents are. We'll talk about those later. The outer core, the liquid second to last layer, it is made of molten iron and nickel, which is heated by radioactive decay. It creates the magnetic field of Earth. And finally, the inner core, made of entirely solid iron and nickel. The temperature and pressure of it squeezes all the metals together so they cannot move and are just one giant metal ball. Now, as previously mentioned, what are convection currents? In the mantle, the material is made of solid bendable material. When the core heats up the rock, it becomes less dense and rises to the top of the mantle. Once it's there, it cools down and sinks back to the bottom of the mantle. Then it heats up again, rises again, and continues the process over and over again, thus creating convection currents. However, we still don't exactly have the Earth as we know it today. After Earth separated into these layers, a theory created by Alfred Wegener suggests that all of our continents started as one megacontinent known as Pangaea, and eventually separated. This theory is known as Continental Draft. The evidence for this theory is the shape of the continents and how they all kind of fit together like a puzzle. The fossils and rocks found across continents are sometimes the same. Some mountain ranges across continents fit together. Fossils found in one continent can be found in others, and climate change. Fossils come from warmer climates can be found in colder climates, such as Antarctica, and glacial scratches can be found in warmer climates. But how does this happen? You're probably wondering. Continents are big rocks and cannot be moved easily, but in the ocean, the seafloor actually moves because of convection currents. Then a mid-ocean ridge is created. This pushes magma out the ridge and pushes towards the continents. The older parts of the seafloor are pushed under, creating not only trenches, but also volcanoes. This is proven by how the seafloor has aged. Near the middle of the ocean, it is actually younger than where the continents are, as well as the magnetic bands when the Earth's magnetic field flips. So that's the next thing I'll be talking about, the Earth's magnetic field. Earth is actually a lot like a magnet. It has a north and south pole. This magnetic field protects us from dangerous solar winds that come from the sun, and it also helps animals navigate, makes compasses work, and is the reason for the aurora borealis. This magnetic field was created by the liquid outer core of the Earth. Believe it or not, Earth's magnetic field changes in two ways. It gets stronger and weaker, and it reverses too. We know this due to the magnetic band across mid-ocean ridges. Now, let's talk about how mid-ocean ridges and other earthly occurrences happen. Convergent plate boundaries. When two continents collide due to seafloor spreading, it creates mountains. When a part of the ocean and a part of a continent collide, it makes volcanoes and trenches. And when two oceanic plate boundaries collide, it creates a trench and an island arc. Divergent plate boundaries. When two oceanic plate boundaries split, it creates a mid-ocean ridge, and when two continental plate boundaries split, it makes a rift valley. Transform plate boundaries. They're a lot simpler, they just create earthquakes. Now, on to the last topic. Hotspots. Hotspots are what form islands like Hawaii. They are a localized source of heat in the mantle that is momentarily under the island of Hawaii. When the Pacific plate moves, the hotspot stays, allowing magma to come up through it and break out and out of the volcanoes. Come up through it and out of the volcanoes. When the hotspot moves, the island shrinks due to rocks and other stuff breaking off of it. And that is Earth. And how it was made. Yeah.